Now it's time to see just how specifications are implemented in the sample app. While the application code does lean on Steve's specification API, there's still plenty to see. Most of what you'll see here is the application's code, but occasionally you'll also see some of the code that's in the Ardalis specification API. Once again, Steve is going to walk you through this demo, and he'll do so from the perspective of how the app retrieves data, starting with the front end.
When we first load the schedule page in the Front Desk app, it loads our Blazor WebAssembly application, which then makes some API calls to fetch the appointments and related data. One of those calls is shown here. It's used to get the list of appointments for the schedule. Looking at Swagger, we can see there are a bunch of appointment endpoints. Our API is designed to serve the needs of the client app. Its endpoints won't necessarily match up with how our domain model is constructed. So it's perfectly fine to have an endpoint for appointments, even though appointment is not an aggregate root. It just means we need to pass in the aggregate root ID as part of the request so that we can get the schedule that owns the appointments. If we test the list appointments endpoint, we can pass in the same schedule ID that Blazor was using, and we get back a list of appointments as expected, and these are in fact the same appointments that are being used in the front end. Looking at the source code for this endpoint, you can see that it's in the API project, in the endpoints folder, in an appointment folder, and within that, we're looking at the list endpoint. Now, when we pass in the request, we're specifying a schedule ID, and if that schedule ID is missing or empty, then we're going to return not found from this API. Otherwise, it uses the schedule by ID with appointment spec to encapsulate the query that it's going to use. On the page in question, we only want the appointments for one day. It's worth noting that this specification does not perform any filtering by date. It returns all appointments for this schedule. We've left a to-do task here for you to implement this behavior by creating a new specification. Now, the specification that we're using here is passed to the repository method getBySpecAsync. We'll look at that in a moment. For now, let's take a look at this specification. All of the schedule specifications are in the schedule aggregate folder in the core project. The schedule by ID with appointment spec is pretty simple and has just 3 details worth pointing out. First, it has a where clause, making sure it only matches schedules that have a matching ID. Second, it eager loads its associated appointments by using a .include statement. And third, it implements another marker interface, iSingleResult specification. This interface is used to mark specifications that are expected to only return a single result. It is required when passing a specification to a repository method that only returns a single instance of a type rather than a collection or enumerable. Considering that this is being called from a list endpoint on the API, this may seem strange, but remember, we are only loading a single schedule aggregate, and it is then just the container for the set of appointments that the endpoint is going to return. The method the endpoint is calling, getBySpecAsync, is defined in Ardalis.specification, as shown here. Note that it has a generic constraint requiring any specification passed to it to have that iSingleResult specification marker interface. The sample code is calling this first method, which just works with one entity type and then returns it. If you need to use projection, though, you can use the second method, which operates on your entity type but returns a different type using a .select. You can use this to optimize queries to return only needed properties. Remember that specifications are useful to define the expected shape of returned data in a query. This doesn't just mean filtering the number of rows using a where clause, but also determining which associations should be brought back with the query and even which columns should be included. Let's see an example of that. Returning to the specifications for the schedule, there is another one called Schedule for Clinic and Date with Appointment Spec. One of the newer features in EF Core is filtered includes, and so by adding an include filter, we can make sure that this schedule, which is being used with a particular clinic ID, will only load in its appointments where they are for a given date that gets passed into the specification. You can use this specification, by the way, as an example when you complete that to-do task that we just saw in the list endpoint. Compare this code to how we solved this problem in the previous version of this course, using custom SQL queries and a custom schedule repository. The specification has replaced all of that with a single specification class containing all the query logic, and the calling code simply needs to create the specification and then pass it to the repository. Unlike custom link expressions that might be anywhere in our application, specifications are easily tested in isolation. In the integration test project, you'll see several different tests that demonstrate the various schedule specifications and ensures they work as expected. These tests use a real database, since .include logic can't be tested with an in-memory collection. For the last specification that we looked at, which only includes the appointments for a given date, you'll see that there's an integration test that adds a number of appointments on different dates, and then uses a repository to fetch back a schedule using the schedule for clinic and date with appointment spec and a specific date. And it verifies that we only get back the appointments for that date and not the appointments that are on different dates, which verify the behavior of many of the abstractions and implementations in our domain model.
Once again, let's begin our review with some of the important terms you learned in this module. First, and most importantly, the focus of the module, repositories, which encapsulate the data persistence logic, add, update, delete, and retrieve. In the case of domain-driven design, we use repositories to focus on aggregate roots. Key to building flexible repositories is the specification pattern, which guides you to encapsulate business rules in a way that they can be passed around and acted upon in other methods, classes, or APIs. You learned about persistence ignorance, which describes objects being ignorant about how they are persisted into data storage. It's another critical aspect of domain-driven design. Steve and I also talked about ACID, an acronym to describe transactions as being atomic, consistent, isolated, and durable. Another acronym we talked about is SOLID, which is a collection of software design patterns.
After introducing you to repositories and how they fit into the DDD mind map, you learned about their benefits and some tips for designing them.
We also addressed some of the debates around repositories, not only if you should even use them, but how to use them, for example, whether or not to return iQueryables. Many of these debates exist because of the complexity of balancing clean repositories with repositories that help you achieve the variations of queries required by your domain.
We introduced you to an often overlooked pattern, the specification, that plays a critical role in solving this problem with DDD. Remember that you are not on your own building specifications. You can lean on the NuGet packages that I created, or just dig into my GitHub repo to pick and choose what you want to adopt. Links are coming up.
Steve gave you a great tour of how repositories are implemented in the front desk application, and then more deeply to see how these repositories are using specifications to provide the rich querying needed in the application.
Here are a number of links to not only my GitHub repo and NuGet packages, but a number of other resources we referenced, as well as some additional ones that we think you'll find useful.
In the next module, you'll learn about two more critical pieces of the DDD mind map: domain events and anti-corruption layers, both which help provide some data pathways between the various parts of your software. Thanks again for watching Domain-Driven Design Fundamentals. I'm Julie Lerman.
And I'm Steve Smith. Thanks for watching.